Module 3 Biasing Techniques. In this presentation, we like to explain collector bias method. This self-biasing collector feedback configuration is another beta-dependent biasing method, and this method requires two resistors to provide the necessary DC bias for the transistor. The collector to base feedback configuration in the circuit ensures that the transistor is always biased in the active region regardless to the value of beta. This DC base bias voltage is derived from the collector voltage, thus providing good stability. The figure represents the circuit diagram of collector bias. The important formulas used in the circuit as given as here. The DC base bias voltage is derived from collector voltage Vc, thus providing good stability. In this circuit, the base bias resistor Rb is connected to transistor's collector C instead of the power supply rail Vcc. Now, if the collector current increases, the collector voltage drops, which reduces the base drive, and thus automatically it reduces the collector current. So, the transistor's operating point remain fixed. Therefore, this method of collector feedback biasing produces negative feedback around the transistor, as there is a direct feedback from the output terminal to the input terminal through the resistor Rb. Since the biasing voltage is derived from the voltage drop across the load resistor RL, if the load current increases, there will be larger voltage drop across RL and corresponding a reduced collector voltage Vc. This effect will cause corresponding drop in base current, which in turn brings IC back to normal. In this circuit, the base bias resistor Rb is connected to the transistor's collector C instead to the supply voltage rail Vcc. Now, if the collector current increases, the collector voltage drops, reducing the base drive and reduces the collector current, and so the transistor's operating point remains fixed. Let us check what are the advantages. Collector bias offers negative feedback. It stabilizes the operating point by reducing the base current if IC, that is the collector current, increases. Requires fewer components. So naturally the circuit design will be simple and it reduces the cost. Additionally, it provides moderate temperature compensation, improving circuit reliability. Applications used in basic amplifiers, low-cost circuits, temperature-stable circuits, and switching circuits.